Thanks MindFuelCept and GDGYYC for sponsoring this workshop.
All right, everyone, it is 6 p.m. Are we excited for our third iteration of the Typeshift workshop? Let me hear any enthusiasm. My name is Eason, in case you have never met me before, and today we have the honor and the privilege to invite Mr. Farhad Bayanati to give us a presentation on the topic of contextual engineering prompts. This is especially beneficial for those of you that are still in school or just entered the workforce, as we will explain how you can use the power of generative AI and contextual prompts to really help you out with increasing your productivity. So without further ado, let's give a round of applause to Mr. Farhad Bayanati, and we'll get started on our day.
Thank you so much, Ethan. It's an honor to be here. Thank you so much, everybody, for coming. That would be a story of... Close it. Okay, sure. That would be just some experience which I had. Is a story of failure which I encountered with and experienced and wanted to share at some point. I know lots of talented people are here. It's just explaining some solution for what experience with. My name is Farhad Bayanati. I'm working for Abbott Laboratories for heart failure department, which is part of the St. Jude Medical for medical device manufacturing. And I'm team lead on the front-end team for the CardioMEM application. So sure, thank you. Yes, we're working better. There you go. Sure. Good. We have partners and sponsors which make this event happen. And thank to everybody who was a sponsor and partner for this, especially for mentors and students who made the Typeshift available for all of us. You see the names. I don't mention the name of people, then thank to everybody. Okay, context engineering, or better to say context engineer prompts is the target thing which I'm going to talk about. That's the way that we use LLMs and AI models every day. We want to hire them to make them a specialist and create some agents to get the better results in the production level result based on whatever we can pass to the LLM. Before going forward with the full context, we need to just review some basic items. Most probably all of you know about that. Just it needs to understand some of these basic things before going ahead. Before this session, we have a few weeks ago, we had Interpret a presentation which went deep through this explanation. If you want to go for low-level understanding of those concepts, I highly recommend you review or go to the presentation with Interpret had. The subject that we're going to start with as a basic are LLMs, how LLMs work, non-deterministic behavior of an LLM as an AI model, attention mechanism. We want to talk about the tokens. We want to talk about the temperature and randomness of the AI models. Also top P as a parameter, which we can control some of those randomness through the LLMs. And at the end, the last basic context, which we are going to talk about, that is the context window. LLMs or AI models are defined as pattern prediction machines. They work to produce the result which you expect by token by token generation. It means they are not thinking, but they are not that much smart, but the tokens are the things which come together to produce the result that we expect. The way that we can introduce or we can explain an LLM, we need to mention that its pattern prediction approach is sequential generation of the tokens back to back. And also we can mention that there is no planning ahead when they try to create or find another token in an AI model. And also it mentioned that real-time thinking is happen. It means that when it tries to find next token, it's a real time. So when finish one token, it goes to the next token. The LLMs and AI models are non-deterministic. It's not like a calculator that you say 2 + 2 would be 4. It's anytime that me, you, everybody use a model to do a query and get the result can be different. And this is the behavior of prediction, which brings some randomness with it. If we come back a little to 2017, Google has an article that they introduced, attention is all you need. This article provided the base of transformer architecture, which is introduction to attention mechanism. Before that, we had autocomplete, for example, in your software, in your application that you used to work with. Sometimes you used to type a word and keep going, and it could bring the next word for you. It had limited option with a few words back to back when you go ahead. But now these LLMs with this mechanism bring you a huge pool of available words, which better we say tokens. And these tokens are the opportunities to get predicted to produce your results after that. There is a link in the QR code for that article if you are interested. What are the tokens? If we want to simplify the tokens, we can say a token can be anything in a trained model. Models get trained with words, with knowledge, with codes, with signs and everything that has a training pool of information they have. And practically, or we can say roughly, we can consider 3/4 of each word as a token. To show that better, we can rely on, can check the tokenizer by OpenAI. If you see this on the screen, this is trying to explain the tokenizer. It chose the GPT-5.x. I go to show a sample on it. This wording, which is on the screen, brings 252 characters and 53 tokens. This colorful portion of the phrases, each one of them considered as a token. As you see, maybe we have a word which is divided with 2 tokens. And if we go to token ID, behind the scene, what exactly which is available for the AI model is this number tokens. If we work a little around it, for example, let's go back to text, you can practice with this. Many words. I want to just show you that even the same word can be different. On the bottom, we have some similar word, and we do the tokenizing. And if you see 6391, 6391 is repeated for the words, but for the many, we still have different token. The many, which is started from the beginning, is different token, which is started in the middle. And we have a topic about that down the road. As the models are just coming with prediction of the tokens, then this prediction means there is randomness. This randomness can be controlled, and sometimes we need to control this randomness. When you use a chat for the querying your models like ChatGPT, like Copilot or something, you don't have these parameters to set. And one of the parameters which we need to set when we work with the AI agents is temperature. A temperature can adjust kind of the randomness and to be more creative or chaotic or to be more specific. When we set the temperature parameter to 0, that would be more deterministic. When we set to 2, that would be more chaotic. Sometimes as a balance with 1, for example, for my agents, which are working to get more accurate in healthcare environments, sometimes I use 0.4, 0.6 to be more accurate and reliable. Another parameter is top P. Top P is defined as cumulative probability. When we talk about the probability, you remember that we are going to prediction. Prediction happen based on the probability percentages. We have a pool of tokens to choose from as a next token that we want to bring for our answer. Then these tokens have different probability percentages. We can set the top P to consider how much probable next tokens in our answer. We set it between 0 and 1, which represents 0 and 100%. Sorry about it. My apologies. And this percentage worked, if you want to explain it better, we have an example here. For example, we question what color is the sky? The sky can be blue, can be clear, the sky can be orange, gray, red, or something. Most probably 60% of the cases, the sky is blue. For example, if we consider, we go 20% of cases clear and 10% is gray. And there is a huge amount of other possibilities to be 100%. If we set the top P to, for example, 90%, or we say the top P parameter is 0.9, we just have 2 tokens to choose based on this diagram that we have. Either would be blue, clear, or gray. If we go for example, 50% or 0.5, the only choice that we have to choose next token would be blue. Then that's the randomness controlling by the top P. We have a big pool of tokens, which will limit the tokens that we are going to switch. Context window, what we talked about token, whatever we work with the LLM or AI model is converting to token. You do a query, you type something as a query to question and get a production level or good answer of that. Then your output and your input converts to tokens. Then you have just numbers. You don't get your answer usually when you use your chat. You keep going with the next prompt and next prompt. Then you keep adding queries, you keep adding the answers back, and your chat gets bigger and bigger. Each token that we pass as an input and output will be considered on the capacity of context window. For different models, we have different capacity. For example, for Grok 4.1, which is from XAI, previously Twitter, recently we have 2 million token capacity on the context window, and for version 4, it was 200 token. To compare them, we have an example that we show with the next slide. Sometimes because we keep going with our chat, we keep querying, we get answer, we are not happy with that, we go for the next one, it keep growing and we get to overflow. When overflow happens, it automatically and silently, before you know, it drops whatever which was in the beginning. It works as first in, first out, and you lose the queries and the outputs that you had at the beginning. There is a problem here that we talk about that later in one of the articles that explain what would be happen in this case. Then sometimes that we go too much, whether we go to start a new chat. Some of the model context windows example are here. Group 4.1 is 2 million token capacity for the context window, and group 4, 256. DeepSeek 128K. Recently, I queried this. I came to this number. You can query your model and ask what's the context window which you have. Sometimes it's important. It's important when you want to feed your model with some extra document and information to be sure that that amount of information which you are passing is considered part of the context window. Okay, that was the basic things which we wanted to review together. I know that you knew about that, but just a review and better explanation and deeper about the LLM and how that works would be good idea if you get back to Interpret presentation a few weeks ago. Before getting to context engineer prompts, we may need to understand some or review some prompting techniques, general day-to-day prompting techniques. Some of the core techniques that we usually use, me, you, everybody use, are standard prompts, whatever we type every day, zero-shot prompts, one-shot prompts, few-shot prompts, and another topic would be the context placement. With standard prompts, you just query whatever comes to your mind. Sometimes we used to search engines to Google or use the different search engines and type your question and get your answer. Still that works, but maybe not efficient. For standard prompts, you rely on whatever model is trained with. You question with knowledge of the model, and LLM bring back the result and the assembled token back together as an answer for you. Another way is, which is subset of the standard prompts, is zero-shot prompts. Zero-shot prompts are standard prompts, but all the standard prompts are not zero-shot prompts. Simply, we can say zero-shot prompts are prompts or queries which you pass without any example. Again, you rely on what knowledge inside and trained with the LLM that you use. And sometimes you see that you don't get a very recent answer because the LLM has cutoff dates. Then there is no example provided on zero shots. The prompt length is short. It's cost effective. It doesn't take that much token because it's short and is fast and relying on the model which you use. One-shot prompts, the only thing different which we have here is the same as before. You rely on the LLM, but you provide an example in your query. The example kind of narrow down or try to help the LLM to concentrate and have attention to the example that you provide. You say, for example, you can go for a translation or sentiment analysis prompt like, example here, classify the sentiment of the following text as positive, negative, or neutral. And the text that you pass is the product is terrible. Sentiment would be negative. What's the sentiment for the other text? I think the vacation was okay. Then you provide the example, you give the guidance, you have the model, you get the query. A few things here that we can consider for one-shot prompts is the best practice for them is you go with a good example for sure. Include every element that is important in your example to get a better answer, and be explicit on what you expect to be in the result, and keep it simple. As far as you consider these things, then as a best practice, you get a good answer. Is one step was better than the zero shot, but we come back down the road to some example that we cannot ignore the zero shot prompts yet. On top of that, sometimes we go for a little more extensive queries with few shot prompts. In this case, we provide multiple examples. Sometimes some people say 2 to 5 is good. Some people say 4 to 8 or 10 is good, but it takes more effort to bring those kind of prompting. For example, there's a rhyming couplet here. The prompt is generating a rhyming couplet about the input. The input was a cat. The provided example was the curious cat, so slick and fat, curled up cozy on the welcome mat. And the same for the other inputs, sky, tree, ocean, mountain. You provided example. You expect to get a rhyming couplet for river. You can give it a try in any model which you want, and you see the answer comes with a rhyming couplet very close to the example which you provided. The takeaway for this is you can provide diversity, you can provide the edge cases, not only the main case that you are looking for, and it can be concise, but better to be complete and more descriptive to consider all the edge that you want to have as a quality produce answer at the end. Context placement. We come to a context placement. There is a research, which the link is here. You can look into that. They chose LLMs to query with feeding some documents on it. And there is relevant document to the answer that they wanted to see. They put the document in different places in the context window. Sometimes they put it in the beginning, that's relevant document, sometimes in the middle, sometimes in the end. The result that came was lost in the middle. My apology. They learned the most important things that we have to query for a query, and we want to feed the LLM as input should be right after the query. It should be at the beginning, at the start. If you put something important in the middle, there is a bigger chance to lose it. And if there is some extra information which is important, better we can still consider them at the end. There is detail about that you can learn and search in the article. That's another technique that we can consider. Then in general, we can say, okay, front load means the quality document and relevant information that we want, we load in the front. We try to avoid that critical information in the middle. We try to close the end strong with some additional important information. And if generally we have very big one, maybe with a very big context window, which possible to lose something in the middle, maybe better we start from a new chat. As you remember, when the context window overflew, you lose whatever which was at the beginning. First in, first out happens. And the most important thing, which was probably in the first query which you had, you lose it. Okay, there is some advanced prompting techniques too that we can review: structured output, chain of thought, delimiter prompting, and personas. A structured output, you remember that you queried a LLM or model and you get an output, but you needed to work a lot at the end. When you get the answer, it's not the answer that, it's not the shape of the answer that you want. Then to avoid those reformatting and reshaping the output, there is a chance that we define the structure of output that we want in our query, in our prompts. There is an example here on the left. Yeah, it says the extract nutrition info from this, put description into JSON. JSON is just data format that we use usually in coding. It defined it to bring the calories in number, protein in number, carbs, and main nutrients as a string, as an array of strings. Then it defined what kind of output we expect and described what we have. We have grilled chicken breast, high protein, low fat, 300 calories with moderate carbs from marinade. The results which I found in the Copilot was exactly which we expected to be in the structure that we defined. It saves your time, is good for integration if you want to integrate your output to other systems, especially when you use the AI agent, you want to keep going with what result that you get to pass to another agent, or you want to share it with other application which you integrate with. And the most important thing is to bring you a consistent format. Chain of thought is a kind of another article that you can go through that. There is a QR code on it. Interestingly, they used zero-shot prompts, which we said zero-shot prompts are prompts without any example, in both arithmetic and logic reasoning queries, kind of. And with just experimenting adding some template to it, the result was way better if we use chain of thought. There is 5 magic word here. Let's think step by step. Whatever you query, if you add these magic words together, these 5 words together, the result would be way more accurate. The study which happened, and you can see the chart and details in the study very deep, the simple query, a zero-shot query without any example, bring 17.7% accuracy in the answer. With adding these 5 words, the accuracy came to 78.7. What was the other options? That this is a chart that I brought out from the article. You see at the very bottom, we have zero-shot prompts. We did a query without any example. The accuracy of the result was 17.7. If we go with some templates adding to that, you could get, for example, let's think a step by step. Accuracy came to 78.7. You could go some other thing like just let's think. The accuracy came 57.5. If you go misleading, don't think, just feel. The accuracy didn't help this template. If you go for something completely irrelevant like abracadabra, it reduced the accuracy. It brings to attention that you could have better prompts with few shots prompting. Spending some time to go with multiple examples, bring a pattern, go for edge cases, trying to bring consistency and provide a pattern to LLM. But sometimes it's time consuming. You don't have time, you can add chain of thought with 5 magic words, which we experience here. Delimiter prompting, when we have a prompt which gets growing, we better to distinguish between the sections. This delimiters help the LLM understand different sections and have better focus, which is the task that the LLM is going to be focused, separated, and what is the context that you provide as an input is separated. That simple technique helps to get more accurate, more consistent with defining the boundaries that you have in your prompts. There's a sample here which is delimited. Delimiters can be anything. There is no specific. Some of them, based on the model, interpret better. In coding, sometimes we use tags. Sometimes we use JSON formats to distinguish. Sometimes we go XML, or simply we can go with the double quote, hashtag, single quote, anything that can be a delimiter. Personas. Okay, role prompting. You want to ask some question from your LLM, AI model. You can define a role for your AI model. You assign that role, it changes the tone and the voice that you get in the answer. you asked, you are a, it says 2 words, but actually it's 3 words. I passed you are a to Copilot and said, is it 2 words? It said, yes, it's a 3 words phrase. I was a joke, but it happened. I tested. It's 3 words, you are a, which considerably change the tone and the voice of the output that you get. It can be different in any subject. If you're a code reviewer, you can say you are a senior engineer focused on security and performance. If you're working with document, you can say you're a technical writer. You can say you're an architect, you're a debugger or something. Then generally, if you assign a role to your prompt that help make better attention and narrow down the result that you get. Then the vocabulary that its model select would be different, more focused on what the role that you assign to the AI. The response structure would be more consistent. Because of the role that you assign as a teacher, as an advisor, as a specialist for any subject that you say, that would be more error-proof. It goes with more accuracy. And generally, the answer that you get is in a more confident tone and the voice. Okay. Then for now, we had some basic, we had some core prompting techniques, and we had some extra advanced things that we can consider, and all of them helping us to make a context engineer prompt. Why we need a context engineer prompt? Sometimes you are with your LLM, you are behind your machine, you query back to back to get your answer. And as we talked about that, you need to work on the formatting, reformatting, and narrowing down the answer that you get in production. You need consistency, you need precision and safety in other cases, in a production level answer that you want to get. When you work with your AI agents, you can be man in the middle in AI agent, but in some cases you are not. The agent is working on behalf of you. Agent needs to produce some answer for you. Agent goes to LLM to take advantage of the knowledge which is in the LLM to bring and produce what you want. As much as possible, you can create a consistent, well-formatted, precise answer, then that's a win for you. There are some elements that make the context engineer prompt in a good way, and it's essential. This is exactly the place which I failed. And the whole thing that we talked about that was based on that failure study. Role, we talked about it already, the persona, which you have a role prompting, you assign a persona to your query, and you need to define a task. You have input, you can have output, and define what you want. You have some constraint in your prompt. You can define the constraints. You can go for capabilities and add some extra thing to your prompt to help the LLM to search. And you have some guardrails. Role and persona, already we talked about that. It changed the voice and the tone of the result that you get. And it's the same as the day-to-day prompting. We can use it and define you are a whatever the subject matter expert that you want to assign, a specialist role that you can assign to your prompt. Task definition, okay, the most important thing is what's your object, what you want to get, and what exactly you want to accomplish with task definition. The different tasks you can assign, you can analyze the data, you can generate the context, you can solve a problem with your defining the task. Sometimes you want to receive just recommendation. Then the second section of your context engineer prompt can be definition of the task that you have. Input specification. When you pass a query to your LLM, you can define the inputs, that the structure of data that you want to pass to the LLM. Sometimes it's important because you need to map the information which you pass to get a better output, to get a structured and well-defined answer at the end. This can be the format and the structure of the input that you have, the domain knowledge, the business context, the extra information that you want to, in addition to the knowledge that LLM has, pass to the AI model. It can be document, can be some extra information to help get the better results. Output specification generally is about the formatting, structure, schema, and requirement fields, whatever you want exactly to get as output. The importance here is it comes to the response that you expect to get. The look and feel of the output would be the definition of that would be here. It can be required fields, can be optional fields, can be technical specification, the type, the shape of the output that you want to expect. Constraint is limits, range, the boundaries which you have. Sometimes you want to get examples, to get a produced answer which comes to a specific performance criteria. Sometimes you want to get a boundary. You say, do not go, do not exceed, do not add, or something like this. All of these are rules that make the AI, how the AI behaves. And can be edge cases, can be explicit provision, like the not exceed more than 500 for 500 characters in the results. Can be some performance requirement that you have. I want an answer. I want the product as an answer that perform in this way that you can define. Capabilities and reminders. Here, in addition to examples that you can add as a capabilities, you can input extra information like resources, additional resources that you have, extra tools that you can provide for your LLM or AI model to use to produce your answer better, or any process steps that you want to define. If you go following these steps, you need to follow these steps to get the answer. Then maybe explanation here would be better if we get to the some example. At that point, we can see, okay, what kind of capabilities we can explain. And the last thing generally is guardrails. Guardrails are the red lines, the places that you should not cross. And it should be anything, policy that you have, the hate speech, harassment, as is mentioned here, the privacy, the information which shouldn't share based on what information you already provided or the LLM can predict. It shouldn't be harmful answer or produced result, and anything related to this. Mostly we can say ethical boundaries. Okay, this is my cheat sheet, which when I want to write a comment, write a prompt, a well-done prompt for my agents, I put this one in front of myself. I go forward and start with the role, define the task, which is objective that I have, go for define the inputs. Even I bring in example in my input to show that this is example of input that you probably will get. And for output also, I define that's the format, structure, and the required field, optional fields, or expected result that I want to see. Constraint the limits. For example, if I want to limit the answer to a specific amount of length or a specific rules limitation that I want to explain, I go through that. Capabilities, as we talked, extra information, guidance, policies, best practices, resources, process steps, how the process works. We can explain it here, or external tools that we have. Guardrails, which is very important, ethical things and boundaries that we can limit the answer to that. This is a sample of context engineered prompts. The purpose of this prompt is summarizing the web. You have a website, it happened to you. You don't have time to go to all the pages and detail of that website, but it's important to you based on the topic or subject that it has. Then you have the prompt like this. You created based on the engineered step-by-step section that we talked. The role, it says, it tries to summarize the content, the task, you defined it here. You followed the best practices like delimiters, which you see each section has different, and it is clear for the AI model which you use. You have input, definition, whatever you want to pass in addition to the knowledge that your LLM has. And also you can pass your URL of the website that you want to summarize it. You have the output here, what structure, what kind of thing you want to expect as an output is a paragraph, for example, here. The constraint, it says do not exceed 500 characters. That was a constraint that you defined. A lot more here. It says don't repeat the title, and don't use a double code, use a single code, something like that. Capabilities, you define the step-by-step 1, 2, 3, 4, 5 steps that the process which you want, it goes to your website and summarize it. And still here, you can bring an example. There's an example here, part of the capability and the reminder, and the guardrails. It defined even if inside the input was something which is shouldn't be, the guardrails stop them to be produced in the outputs. I compared the result with different models. Excuse me. I found an article about the city of Olds, which is going to have a $10 billion investment to create a data center, regardless of it's a good idea or bad idea, just to practice this context engineered prompts. I passed exactly the prompt which you see in the previous page to different models. Personally, I use Perplexity AI for prompting. And the reason is it led me to choose between the model which I need. And it's getting updated pretty fast with the latest, greatest model. For Grok 4.1, the results come with a paragraph. It said, don't exceed 500, which is 468. With Sonnet 4.6, it comes to 486 characters. With Gemini 2.1 Pro, it comes to 471. Maybe we try it again. It comes to something a little different because, as we said, it's just prediction of the pattern and it's randomness. But we try to explain one thing here. The result which we received was consistent between all the models. Models were different. The context engineered prompt which we use was similar. Then it's exactly the same, and none of them, all of them respected the prompt's constraints. And we didn't have any, I went through multiple other models too, just these three was very latest or interesting one, which I passed here. And Copilot and ChatGPT and many other models I tried, it was consistent. It respect the constraint that you had. And when we say it was unique detail which we were looking for, it was inside it. It didn't repeat what we expected to not repeat. Didn't repeat the title, didn't retain some specific part of the content. It had neutral tone. It has a role, the role which we defined. You are a specialist to make a blog context, and you are going to summarize it. It used the same tone for all of them. And the metric, you could see some metric in all of them. For example, here we had 2,000 construction job here, and it talked about the other one, 2 million square feet facility. The other one talk about 1,000 permanent job in generation. Those metrics were included in result after all of the models. In real world, you have many samples that you can use your context engineered prompts. Like the thing which I used for, we have a ticketing system. And this ticketing system has a lot of tickets in, we call it Jira, it's by Atlassian. And we needed to summarize it. It's time consuming. The tickets has sub-tickets, sub-tasks. The task has comments and results. Then we needed the AI agent to go through all the tasks and bring us first the status and some important comments gather together and summarize different steps of these Jira tickets. Front-end code reviews, day-to-day we do that. I do that for team, for myself. And regularly it's, and I encounter with big context window when I work on it. When Ben worked with this coding, the context window which I see on his system was huge. Looks like he's dealing with very deep code. SQL Query Optimizer was another example which I went through. There is an agent that could go to look into your query, which SQL query which you generated, and figure out the bottlenecks, the optimized version of that, and come back to you. And the Portfolio Optimizer was another one. The whole advantage of this is this technique is universal. It works in different industry, different topics. You don't need to limit it to coding or IT environments. You can use it with other industries like healthcare, law, study, something like this. And it just needs 7 essential elements, which is not too much hard. You can make it one time, use it many times. You can have a library of your good prompts. How much it will be valuable, I don't know. This topic is going so fast, AI. And it brings you consistent performance. That exactly thing which I needed, which I felt at the beginning, it led me to go to some study, come with some solution for my AI agent, which was back-to-back was failing, to get consistent in performance and the output to be able to integrate with many social media environments or many other tools which is available. That was a
Wow, what a speech that was, what a presentation that was. I hope you all enjoyed the presentation from Farhad. So now we will be taking questions from the audience alongside with our with our online audience. So let's start off with our in-person audience here. Are there any questions that we would like to ask Farhad? That's good. Yeah. Yeah, sure. I think that might be me.
Hi. So the only way I was able to integrate with Jira was with MCP with GitHub Copilot. I was wondering if your Jira Summarizer uses a different method.
We went token through the APIs. You can have access to your Jira with the API. Everything that you can do. Even you can create the new ticket, subtask, task, epic, or you can query to get the comments back from your ticket, which you have. You can prioritize them. You can sort them based on the timing. And most thing which we did was summarizing for regression analysis. That was a use case that we had.
Then you have to create a Jira account.
All of them goes to like concept study of the administrative when we talk to that. There's not an issue when there's a as it is choosing. Yeah, so the M specifics was actually just for tokens.
Online, we can't hear you, so if you could just wait till he said yes with the mic, that would be, we would really appreciate it.
Yeah, so what I was just saying was that with MCPs, token management is not as efficient as when you make your calls over API. So if you have the option of making API calls directly, it's just better to just use that when interacting with LLMs over essential calls that you have to make. Thanks.
Thank you for your response. Are there any other questions from their? Oh, we have a lot of questions from our online audience, and yeah, I would just like to So one of the questions we got from our online audience is that LLM generated content, context files has a marginal negative effect on the text success rates, while developer written ones provide a marginal performance gain. So what is the best way to balance between the efficiency and the efficacy of it?
That's a hard question. I don't have an exact answer for that. I follow the specific rules that we explained. We talked about that to bring a better query, better prompts, but can be open. Everybody, if somebody have a better answer, I go usually with the rules that we talked about that and with experience. And thank you, sir, about the answer about the MCP. As you mentioned, more cost effective because it uses less token when we go with the API. It costs us less, especially we use the AI agents. The cost is important for us. It's huge amount of tickets.
Thank you for that question from our online audience, and thank you for our response. Are there any other questions from our audience? Yes.
Yes, thank you for your presentation first of all. So you did mention about the context size and the AI agent misremembering or forgetting the first prompts. But from my personal experience, I think most of the LLM that I've had is it starts breaking at 50% context size, and then at 75%, it actually warns you that, oh, I'm filling up my memory. But my true question is, so when you're hitting the context limit, and you said you want to clear the context size. So what is your workflow to, if you want to continue from that previous chat to a new chat to clear the context?
Thank you so much for the question. Depends where we encounter with that. If you're chatting or you're in an AI agent. I guess your question was in AI agent. You're chatting? Okay. Then you need to change your model. Because you hit the overflow, you don't have extra space for your context window. Use Grok, for example. Grok 4.1 is 2 million token. It helps you.
I guess my question is, how do you continue from that? So once you hit your context limit, how do you continue from that? So I guess my workflow is try to summary and then export it to the memory, but how is your experience and what would you do in your experience?
Sure, that's a good approach. Yes, you summary what you have already to reduce the size, and you go for a new chat. Probably, yeah, definitely. I have to go to new chat, but whatever information, important information which I have, if I was happy with the previous answers, I keep them, summarize them, format them, and bring it back the same way that you do. For AI agent is a little different. I need to do error handling on the AI agents. And also, I need to keep the memory. Otherwise, I will lose. And that would be another concept or talk on top of the context engineering prompts. Sometimes for those mechanisms that we want to make everything back to back working for us in content with issues, you go to context engineering. That's a little different. In context, in LLMs doesn't have memory. You get to the limits. No memory. You have context window with the limit. Context engineering environment that you provide has memory, short-term memory, long-term memory. It has state management, what state you are. It has some extra tools, and it has RAG sometimes. Have access to your document. You don't need to fit them all to pollute your context. And at the bottom level of this context engineering is exactly context engineer prompts, which help you.
Thank you so much.
Okay, let's take a look. So Cassie mentioned that proposed a question: who, in the context of what companies and what countries are leading in AI and specifically advanced contextual prompting capabilities?
Very interesting question. I don't know. Maybe. I don't know, to be honest. Oh, but one thing we can share here. Still we can, okay. You want to go to top models, top LLMs. You can, based on this question, you can go to arena.ai. No. Oh, Spectrum. Okay, and there is a battle mode over there. You can put them in the battle. Okay, there's a leaderboard. Arena is Berkeley based. It was previously LM Arena. They changed it to Arena AI. I generally use when I want to go for the best or finding what other opportunity I have. Sometimes I don't go to the best because I don't want to spend that much budget. I go for somehow the worst or the middle, based on if it covers my production result that I expect. Here you can see, okay, if you're going to code, Cloud Office 4.6 is the best one. To text is something else. To vision, to text to image can be different. GPT image 1.5, Gemini 3 Pro is another thing. And generally, if you want to find the best, maybe RNAi is one of the good resources to find the answer.
Thank you so much. Are there any other questions from our audience, both in person or online? Yes, person.
Thanks. You said something really interesting about agents, that an agent will talk to an LLM to get their knowledge. And we've been working with the Google Vertex 80K creating agents, and they seem to be fairly knowledgeable. Like, are they less trained than an LLM? And how would it work with that as they talk to each other? Like, where does the knowledge gap happen?
Generally, if your LLM or model is not trained on well enough, maybe there is other resources that they're looking for. Each LLM or AI model which we have has a cutoff date. it trained till a specific timing. You can question your model or AI LLM. What is your cutoff date? Some of them answer you vaguely. It says, okay, I don't have cutoff date, but some of them has cutoff date. But in addition to training information they have access to resources, online resources, different knowledge-based document or information they have. Maybe that's the way, if it's not trained.
Thank you so much. Thank you so much to Farhad. This is that will be the last question we'll be taking. So Farhad, that was an amazing presentation. So over here we actually do have a present for you to thank you for your contribution to our program. So please accept it. Yes. And we would also like to give a shout out, a really huge appreciation to our lovely sponsors, which is Mindfuel YYC, Google Developer Group of Calgary, and CEPT. Without the support from these companies, Typeshift would not exist today. Typeshift would not be where we are today, and we really appreciate them for their in-kind support. And just to our audiences here, if you have the time, please make sure to scan this QR code to provide us with any feedback. We will be sure to take these feedbacks into consideration and deliver them in our next iteration. And speaking of which, our next workshop will happen on March 10 and March 14. It will be very different than our regular workshops. This one will be a very hands-on model where you actually have the opportunity to build something with the support from our guest speaker and our guest mentors. So thank you all for attending our workshop today. We really appreciate your time. Enjoy the rest of your lovely evening. If you could, please stay here just for a quick photo together. And thank you all. Have a great day.